Good day everyone, I am Iko and today I'll be taking you biology from exquisite tutorials. Okay, for those two, I believe this should be AB 101, then this should be AB 1 to 4. Then it can also have different course codes in other universities. But today we are going to be treating macromolecules. And other macromolecules, we are going to be treating carbohydrates, protein, amino acids, and fats and oil. Okay, first of all, let's start. First of all, what are macromolecules? Macromolecules. Well, macromolecules can just simply be defined as giant molecules, large molecules. They are polymers that consist of subunits. These subunits we also call them monomers. Now, these macromolecules are of different types. We have the carbohydrates, we have the proteins, we have the amino acids, then we have the fats and oil, also called the lipids. Okay, now, starting with the first, which is the carbohydrates. Okay, well, from our secondary school and primary school days, we're told carbohydrates are energy-giving foods. But today we'll be looking at carbohydrates on a more broader prospects. Now, basically, what are carbohydrates? Now, carbohydrates are polyhydroxy compounds. Carbohydrates are polyhydroxy compounds which contain carbon, hydrogen, oxygen, and aldehydes or a ketone group. Now, like I just said, carbohydrates are polyhydroxy compounds which contain carbon, hydrogen, oxygen, and an aldehyde or a ketone group. Now, the general formula for carbohydrates is given as CH2ON. Now, carbohydrates were initially known to be hydrated carbon compounds. This was because during the primitive times or during the times of old, it was thought that carbohydrates were just hydrated carbon compounds. Okay, now we'll be looking at types of carbohydrates. We'll be starting with the monosaccharides. Now, monosaccharides are the simplest form of carbohydrates. Now, from the general formula, we have CH2ON, where N is greater than or equals to 3 for mathematics. You know that this can either be 3, 4, 5, 6, 7, 8, 9, 10, till infinity or whatever. Now, monosaccharides are the simplest form of carbohydrates. Now, monosaccharides can either consist of carbon compounds from N equals to 3 to N equals to 7. Now, when N is equals to 3, it is called a triose. When N is equals to 4, it is called a what? A dextrose. When N is equals to 5, it is called a pentose. When N is equals to 6, it is called a hexose. And when N is equals to 7, it is called a what? Heptose. Now, these are the basic forms of monosaccharides that we have. N equals to 3, we have triose. N equals to 4, we have dextrose. N equals to 5, we have pentose. N equals to 6, we have hexose. N equals to 7, we have heptose. Now, monosaccharides can also be subdivided into whether they are the ketoxy or the aldoxy. Now, we can either have the ketoxy sugars or the aldoxy sugars. Now, what do they mean by ketoxy or aldoxy? Now, we know from chemistry the aldehyde group is given by ROCOH. This is the aldoxy group, while this is the ketoxy group. RO prime, then O. This is the ketoxy group, then this is the aldoxy group. Okay, basically we are going to be looking at now for n equals to 3, 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 we can either have a triose sugar that will belong to the ketose, or a triose sugar that will belong to the what? Aldose. Now remember I said that carbohydrates are polyhydroxy compound which contain carbon, hydrogen, oxygen and an aldehyde or what? A ketone group. Now let's look at two different types of triose sugar. Let's use it to explain what I'm trying to say. Now let's imagine we have this triose sugar. Let's imagine we have this triose sugar. And we have this other one. Now, bear in mind that both of them are triose sugar, but the only thing that differs is these functional groups. Now, this is also called glyceraldehyde, while this is also called dihydroxyacetone. Now, note what differentiates them is that this, we have the aldehyde group on the carbon 1. Now, this makes it what? An aldose sugar or an aldose. Now, this has the ketone group on inside the carbon compound. Now, this will make it what? A keto sugar. So, this a triose sugar can also have the what? The aldose sugar or what? A keto sugar. The same thing with the textures. Now under textures we can either have erythrose or erythrulose. In other words, for n equals to 3, under the aldo we can have glyceraldehyde. Then under the keto we can have dihydroxyacetone. For n equals to 4, we can have erythrose. Then under the keto we can have erythrulose. For n equals to 5, we can have ribose and we can have ribulose. For n equals to 6, we can have what? Glucose. And here we can have what? Fructose. Bear in mind that there are different types of hexose sugar. There are many, they vary. We have glucose, sucrose, fructose, galactose, and many more. But just bear in mind that a monosaccharide can either be what? A triose, dextrose, pentose, hexose, or heptose, and they can either be divided into the what? The aldose sugar or the what? Keto sugar, which I'm just trying to explain this. And note, both the aldo and the keto sugar, they are structural isomers of each other. Meaning, the aldo sugar and the keto sugar, they are similar, but they are what? Structural isomers. Structural what? Isomers. Structural isomers. Structural isomers because what? The only thing that differentiates them is what? Is the spatial arrangement and the presence of the what? Functional group. That's what makes them what? Structural what? Isomers. Meaning the structural isomers. Let's take a look at the structure of glucose. Let's say we have glucose. Let's say we have glucose. Let's start with glucose. Let's say we have glucose. Now this is the formula for glucose. And let's say we also have its keto sugar, alongside with it. Let's say we have the keto sugar alongside with it. Let's say we have the keto sugar. Now, if you observe from the formula for glucose and from the formula for fructose, you will observe that they are basically the same thing in terms of the arrangement of the what? The hydroxy compound. So the arrangement of the hydroxy compound. Now, what differs is the fact that the functional group. Here we have the hydroxy functional group on the carbon 1. And here we have the what? Ketose functional group on the carbon 2, making them what? They are similar, just that they are what? Structural isomers of what? Each other. Now, this basically is is a very in-depth knowledge of what monosaccharides. Let's take a quick review. Therefore, we said monosaccharides can either be what? Triose, tetrose, pentose, hexose, heptose. Then we went on to say that the general formula for the carbohydrates are CH2O, and where N can either be greater than or equal to 3. The next, I said that carbohydrates, monosaccharides specifically, can either be the keto or the aldo. Now, where I said that under keto sugar, we can have the triose. Under keto sugar, there we have the dihydroxyacetone for N equals to 3. We have the erythrulose for N equals to 4. We have the ribulose for N equals to 5. We have the fructose for N equals to 6. Under the aldo sugar, we have the glyceraldehyde for N equals to 3. Erythrose for N equals to 4, ribose for N equals to 5, then glucose for N equals to 6, where I went further to show us the formula for glyceraldehyde and dihydroxyacetone, where I said this is an aldo sugar because of the presence of the what? The aldoxy group on the carbon 1, and this is the keto sugar because of the presence of what? Because of the presence of the ketosy group in between the what? Carbon. So that is it for monosaccharides. Then next, we shall be taking a look at disaccharides. Now, disaccharides. Now, what are disaccharides? Put this in mind. A monosaccharide plus a monosaccharide is equals to a what? A disaccharide. So a monosaccharide plus monosaccharide equals to a disaccharide, but both of them should belong to the same family. What I mean by the same family, to the same number. Let's look at, from when N equals to 6, let's look at some very common disaccharide. First, we can have sucrose. Sucrose is equals to glucose plus fructose. Glucose is equals to what? Glucose plus fructose. We can have lactose. Lactose is equals to glucose plus galactose. While another very popular one is maltose. Maltose is equals to glucose plus what? Glucose. Now, sucrose is a sugar. Sucrose is a very common sugar, like the one we commonly refer to as sugar. Lactose is the sugar found in milk, while maltose is the sugar found in malt sugar. Maltose is sugar what? Found in malt. Now, these are common disaccharides. Now, how do disaccharides form? Now, during the combination of two monosaccharides, they form by bond linkage, known as the word glycosidic bond. Glycosidic bond, meaning two monosaccharides come together to form a disaccharide with the aid of a glycosidic bond. Where we have sucrose will be glucose plus fructose, lactose glucose plus galactose, maltose glucose plus glucose. And bear in mind, glucose is a aldoxy sugar, fructose is a ketosy sugar, galactose is an aldo sugar. Aldo sugar. In fact, it is very similar to glucose. It's just the position of the hydroxy group that makes it different. On galactose is something like this. Galactose is something like this. Galactose is something like this. Now, if you look at galactose and if you look at glucose, you observe that both of them are what? Aldoxy sugars. But it's just the position of the what? The hydroxy group. Position of the hydroxy group that makes them what? Different. So that is lactose will be what? Glucose plus galactose. So that should be it for disaccharide. Okay, so far we have looked at monosaccharides and disaccharides and carbohydrates. In our next class, we'll be talking about polysaccharides. And if you have any question, please, you can go to the comment section and ask a question. They will be answered immediately. Thank you.